So in the last week, you have started the inventory management models. So they mainly talk about how to solve the inventory problems analytically. So in this lecture, we try to talk about when the problem is more complicated, or if you choose not optimal order quantities, what the system performance will be. So we'll go to the simulation models for inventory problems. The learning objectives of this lecture is to be able to construct simulation models for inventory systems in Excel. We have actually tried to build different types of simulation models. So here, methodology wise, actually no much challenge. So here we mainly talk about how to realize the inventory control process in Excel, and then reapply the methodologies we talked about the simulations, and then we can talk and then we emphasize the scenario manager in the what if analysis in this lecture as well. So first, let's see the inventory systems. Hopefully you have learned a lot about inventory systems. Inventory systems are broadly applied in almost any businesses. If they try to, like retailers, you try to sell the products to the end customers, or like the manufacturers, they need to actually renew their raw material or components in order to produce the final products. So inventory basically is a most general problem. They're also related to the waste management, and then inventories normally occupy the business capital, so it's very important. You don't want to keep the high value in the inventory, but at the same time you would like to satisfy the customer demands, and in order to achieve the optimal revenue or maximum revenue and profit. And then the question here we are going to look into is a single product inventory system. We're interested in knowing what the consequences different ordering policies will have, and then based on your understanding about analytical inventory models, then let's see if you do not follow the optimal decisions or solutions, what the system will perform. And then we, of course, suggest you to build or construct a simulation model, and then you can investigate different alternatives. At the same time, you also beware of the variance of your performance. So, for example, the analytical solutions normally give you the expected performance, so expected costs or revenue or profit. So we see this is the E of your performance, but by simulation you can actually find the expected performance. At the same time, you can also find the variance of your performance. And then optimal solution give you the, for example, optimal order quantity or the order time, and the simulation give you a chance to try any other possibilities. So do you have actually other, you will understand your system very well by trying different alternatives. So let's start with the textbook example. So there is a store, it's a hardware store. So they sell the electronic drill. So it's basically it's a tool. And then they observe the demand for this item over the last 300 days. And then they count the frequencies of these demands. So the demand normally is a range of possible demand could be no demand, 0, or 1 unit, 2 units, or 3 units, or 4 units, or 5 units per day. So basically we have a discrete possible demands, and the frequencies is actually how many days you observed the number of demands per day. So for example here, for the 5 0 0.1 actually equals to, you observe the 3 days, you have the demand at 5, and the total days is 300 days. So that's how you get 0.1. And then we know when at the end of the day, inventory is at or below the reorder point and order is placed. So that's a term you should know about. So we're talking about the reorder point and a new order. So when your inventory level is below a threshold, then a new order will be placed. So lead time can be 1 day, 2 days, or 3 days, equal probability. Then there's 1/3, 1/3, or 1/3. 3 occurrence with equal probability. So this is again a discrete distribution. And the cost, so by the way, I just see something more about lead time. Lead time is the time, for example, you have a timeline, and lead time is the time. So in the T1, you place the order, but this order will not arrive to your, so that is your inventory, and then you order the quantity, but this quantity will not arrive to your shop floor or your company until a while this item will be delivered to you. So at the time 2, so at the time 1, the event is place order. In the time 2, this order actually arrive to your set. So this time between T1 to T2 is called lead time. So it's a time until the products are delivered. And then we see the cost. Cost is multiple types. So we see the ordering cost, holding cost, and stock out cost. Here we assume they're all deterministic. So we know exact unit cost for order product and holding the product, and also stock out cost. And the question is when to order and how much to order. So that's actually the decisions normally the companies need to make. So in order to construct the model, we actually need to have several important values. So here we're talking about the beginning inventory of the day 1. So it's and also equals to the ending inventory of day 1 day before I-1. So units received on the day is the order quantity times the number of times order has been placed, which arrives on day I. So if these equations do not make sense for you, you can always check the simulation, Excel simulation model, then you will understand. Because given the lead time, you probably ordered multiple times, and the orders will only arrive after a certain time. We know you have this stochastic lead time, 1 day, 2 days, 3 days. So you always need to check how many orders actually ordered and arrive at the same day. And then available inventory at day I. So beginning inventory at this day plus units received on that day. So that's a total updated inventory. And the demand at the day I equals to the random number following the distribution. So this actually is a stochastic input for your simulation model. Given we know the discrete distribution, easily you can use lookup function in Excel. And then we have the demand fulfilled and on day I. So that's actually is a minimum between the day, the available inventory at that day and the demand required. So that's actually can also be realized in your Excel model more intuitively. if we continue to see the logic of this inventory system, then we also need to know the ending inventory on day I. So in each day, if you use available inventory minus demands, then you actually get the final inventory on the day. And then we have stock out on day I. So this actually depends on if you have sufficient inventory. If you do not have sufficient inventory, then you actually risk a stock out. So here it depends on if your demand is greater than available inventory. So again, this never below zero, and the ending inventory on the day should also be equals to or greater than zero, and this actually should also be greater than or equals to zero. So these two values, you will see they will never be zero at the same time. It never be positive at the same time. So if ending inventory is positive, then you do not have a stock out. If your stock out is greater than zero, then your ending inventory will always be zero. And then we continue to see we have ending inventory plus order on the day I. So this is also calculated in your Excel. So your ending inventory plus the order you played in the same day basically is a inventory position. So that's you're supposed to have this inventory. This will actually, to avoid, this value will avoid you to repeatedly reorder before your order arrive to your place. I will explain that in the video, and you will see that. And the place order, this is a decide. So this is a decision, place an order or not. So if your ending inventory plus your order, basically we say if your inventory position is less than or equals to reorder point, so your threshold, then you order. Otherwise, you do not order. So if this value equals to 1, then you place an order. If the value equals to 0, then you do not place an order. And then lead time. So this is actually also a random number or random input for your model. So it's a discrete distribution, and then you can use a lookup function as well, or you can directly use a discrete distribution. And then arrive on the day. So this actually this day plus lead time plus 1 day, then your order is actually arrived. So that's basically is a lead time plus 1 day. So you have a total 1 day lead time, stochastic lead time. If the lead time is 1 day, then you actually arrive day is current date plus the lead time plus 1 more day, because this new inventory can only be used at the beginning of the day. So we continue to see the Simpkins hardware stores inventory decision problem. So now we first try to find out the analytical Q and R. The idea is actually you need to find the first expected daily demand. So this is actually the expected demand per day, and then you calculate the fixed order cost, so it's given, and the daily holding cost, so it's the daily holding cost, and then average lead time is 2 days. So you have the 3 possibilities, equal probability, then of course you can calculate average lead time is 2 days, or we can also see this is expected lead time. If we use all these expected values to try to calculate economic order quantity, then we can see we can do the calculation based on the EOQ formula. So EOQ formula gives you the optimal order quantity, always optimal expected order quantity is 75 units. And the reorder points, we can use the safety stock formula. So you have the expected value for lead time. So expected demand in lead time, D times L. Then safety stock depends on your safety factor. So search if we see the safety factor equals to 25%, then you times lead time demand, expected demand in lead time, then that's a safety stock. So you plus them together and you get 7 units of a reorder point. So this model, the inventory control process actually can be realized in the Excel by a dynamic process. Now you can see we start from the column A. So this is actually different days. For example, you're supposed to run for 25 days or 200 days or 1 month or 1 year. Then you have actually the days. For each day, you generate actually the demand. So we have actually simulate random demand in the column E. And then in the column K, you generate random lead time. And then during each day, you evaluate. So beginning inventory. So you evaluate the inventory positions, inventory level, and then you use the current inventory to satisfy the demand. You lead to lost sales or stock halt, or you actually satisfy the customer's demand. So in this Excel layout, they just explains, they explain how this customer service or the sales process actually is realized in practice. And in the end, you actually get the performance measures in the column M to column P. Now you can see you can calculate holding cost. The holding cost always related to your end of period inventory. So here we have end inventory per each day is in the column G. So here, and then use this value, you can calculate holding cost. And then similar, you have the holding stock out quantity, then you can calculate stock out cost. And then you can see you have this place order or not. So column G, this is related to your order cost. And plus them together, you get a total cost. But this process basically aligns with the logic of the customer satisfaction process. So you decide if you have a stock or you do not have a stock, and then you collect the statistics or in the end when you actually implement this rule. So here we also have this yellow cells. They are basically a parameter for your problem. So these parameters, including order quantity, is Q, reorder points is 5, so order quantity is 10. So it's just one random example. You actually can give different order policies. So the minimum lead time and the maximum lead time and the holding cost and then stock out cost and order cost, these are all unit cost. And the demand information is a discrete distribution. So the textbook give you all the details about this model. So strongly suggest you to go through the Excel workbook and also the textbook explanations. So after you build the single replication of your simulation, then you can use a data table. So this actually is also what we have talked about. So you can, for example, you run one single replication for 1 month. Then if you run 200 replications, that means you actually run 200 months. So you can also do this. Furthermore, you can see now we have only consider one specific policy for your reorder point and order quantity, but actually now you equals to 5 and 10, if you consider other possibilities, for example, can you consider the EOQ quantity we calculated? So, and then it's 25 and 7, or other policies. So that's actually the essence of simulation. You can try different policies, and then at the same time you can see how the holding leftover inventory stock outperformance and also the total cost. So according to the previous calculation, so you can actually consider this as scenario 1 is a current scenario. Scenario 2, you can change the order policy, and then you can also do scenario 3. For example, we had a 75 and 7. So this is a EOQ value. So this actually is a safety stock. So you can try many different scenarios. Then it requires requires us to use the scenario manager in Excel. We have talked about the scenario manager in the revenue management model, but here you can see the details about how to generate new scenarios with 2 variables. So now you can see the scenarios for this reorder point and the order quantity. They both become the component of one policy. So now you can see here, when you choose the change cells, you actually choose both R and Q, so a reorder point and order quantity as order policy. Now you can see you can change the order policy. So for example, now you add a new policy, Q equals to 12, R equals to 5. Of course, you can add more. This slide also shows the continue of making scenarios. So now you give the values to your scenarios, and now you can see the value of your scenarios. And then next step, you report the type. So you can decide to report a summary or you report to a pivot table. So normally we just choose the scenario summary, and the result cells you can choose where you want to put them. So here this result cells is the cells you're interested. For example, if you want to report both holding costs, stock out cost, and the total cost and ordering costs, you can actually choose all these cells. All these values will be returned to your output. This is an example output from the Simpkins hardware stores inventory problem. Now you can see apart from the current values, so we have the current scenario. We'll also add 1, 2, 3, 4, 5, 7, 6, 7 new scenarios by increasing the order quantity and change the reorder points. If you're interested, you can actually add other policies and see if the cost will be reduced. So then the second part is the result cells. After you got this report, you actually can change the name. For example, if it's a holding cost, you just change the name and make it more comprehensive. So far, we have talked about how to construct a simulation model for the inventory model based on textbook example. So here we also have the exercise problem from textbook 10.24. So if you would like to know the original problem statement, you can just go and check the textbook. Otherwise, we just outline the main parameters and the information for this problem or for this inventory control problem. Then we try to construct a simulation model and evaluate the performance of different inventory policies. So let's see this company or this shop called Lee Appliances knows that weekly demand for high-end microwaves is normally distributed with a mean of 25 units and a standard deviation of 7 units So demands are integrals. So we assume you have a normal distribution with demand. So you can see demand is a normal distribution with 25 mean and 7 of sigma. So this shop replenishes its inventory. So replenish means you just reorder or renew by ordering 300 units from the distributor whenever its current inventory reaches 70 units. So it sounds like a continuous replenishment. So the lead time in weeks to receive an order from distributor follows a discrete distribution. So you need to go to see the Excel cell or the question to see what the distribution is. So basically the lead time need you to use a lookup function to generate with the different discrete values. And the cost to hold 1 unit in inventory from 1 week is to $20. And the cost to place an order with the factory is $300. So this actually is fixed ordering cost. So this is an inventory holding cost. And stock out cost also given is $100 per unit. So that's actually reasonable to have a rather high stock out, because we assume its stock out actually is higher than the holding cost, and then also because you lost a good view of your customer and so on. So stock out cost normally is rather high, so that to penalize stock out, to avoid stock out. And the initial inventory level is 140, so that means I0 equals to 140. And then now ask you to simulate 52 weeks. So we want to simulate 52 weeks of the operation to calculate the total semi-annual cost. So we're interested in the semi-annual cost and the percentage of stock outs for the period. So here I add one extra thing is about how to actually generate random demands based on the normal distribution. So now in this problem you can see, I put it down a bit, and you can see we know the demand actually is a normal distribution. So that's a distribution. So we have a normal distribution for demand with a mean of 25 units and 7 of standard deviation. If I want to generate a random demand for 1 week, for example for week T, I'm going to generate one demand for this specific week, then we need to use actually the demand inverse function, because we remember you need to have a random number, RAND. So this actually is in the range 0 to 1. And then if you use a normal inverse function in Excel, you actually can directly call this random number in your distribution. Then you find a corresponding X or demand value based on your distribution and standard deviation. So this actually is a normal inverse function will generate a value based on normal distribution. However, we actually also requires the demand is the integer values. So we actually need to round up. So in Excel, you can continue to think about use a round function to round this distribution into round this continuous value into integer values by add a value of parameter of 0. And then remember the normal distribution may generate a negative value for you. So we always accept the positive values. So if you get a negative random number, you just take this as a 0. So that's how you generate a random demand. So you do not need to know this formula right now if you did not try Excel. But when you try the Excel setting up, just remember here is the formula you can use to generate random demand. I think here is a tricky problem for the second statement. So Lee replenishes its inventory by ordering 300 units from the distributor whenever its current inventory reaches 70 units. It sounds like a continuous replenishment policy, but in our simulation, we actually try to simulate this process week by week. So we actually means whenever the week you got the inventory level less than your reorder point, you will order. So that's not really continuous. So by implementation in Excel, we actually make it a periodic replenishment. Here are the 3 questions for this exercise. So you need to construct your simulation model and use a scenario manager to evaluate the different policies. So here we're talking about a fixed reorder point R equals to 70. Then the Q value can be different values here, 250 and then to 350. And question C is actually to fix your order quantity Q equals to 300, and then the reorder points can be different values. A little bit more than necessary. So if you do not actually remember what the reordering system or even inventory replenish policy is, so actually try to plot this, then you can think about it. When you construct your simulation model, how do you actually choose the value? So we are talking about a demand satisfaction process over time. And then at the beginning, assume this is the time 0, it's just start of your simulation. Then you have a inventory I0. So that's actually the initial or beginning inventory for T0. And then we assume the customer arrives from the T0. So you actually, from the first week, you will have some demand. So in the week 1, week 2, and then, so this is week 1, this is week 2. And then we're talking about using the current inventory or available inventory to satisfy your demand. So basically, your demand will drop to, in the end of week 1, you satisfy the D1 in the week 1, and your inventory dropped, and then you generate another. So we'll assume we have a reorder point threshold somewhere. So this is a red line. And then in the first week, we can see the end inventory or the beginning of inventory for the week 2 actually is higher than reorder point R. So you actually do not need to order anything, then your order decision is 0. If the second week you have more customer come, for example, the very high demand, so you actually have a deep draw. So here you can see by end of week 2, before week 2, you can see already you have the inventory, available inventory, or we call it inventory level, actually already go cross the reorder point. Then that means you need to order in the week 2. So week 2 now is current inventory level is less than R, so you should order. Then you actually supposed to order a quantity with the amount of Q. But this ordering will not immediately arrive to your warehouse, so you probably need to wait for a while. We assume this is a lead time. After a while, this order will arrive. But during this period, you will continue to actually satisfy your customers' demands. So if your inventory actually crosses the zero line, that means you actually have a stock out. And then when the lead time comes, you actually got your order arrived. So now you got a new inventory level because you have the ordered quantity arrived. So you just repeat this process to make decisions about when you should order and how much you should order, and when you have you just observe when you have a stock out, when you actually have a leftover inventory by end of each period, and then you just record all these measurements in your simulation calculations. Then in the end you can actually do a statistical analysis about the performance. Suppose you have you have constructed the simulation model. Then we have actually applied a scenario manager. Now we get this output. From this output, we can see we have 5 scenarios, and then obviously when the Q equals to 250, now you can see the average cost over 200 replications or something standard deviation actually is the lowest. So now if you see the total cost and the variations, so that's actually suggests you can come up with a suggestion. Okay, the current order quantity 250 actually gives the best performance. So now if we fix the order quantity, so now you know the order quantity even equals to 300, and if you change the reorder point, now you can see when the reorder point is 60, actually give you the best output from your simulation. So you can see, okay, probably the best R can be 60. But this comparison only limited to the values you have tried. So this is purely based on this exercise. You actually have the freedom to try whatever you're interested in. This is the essence of simulation. So it's cheap. You can just try whatever values or alternatives you're interested in. So we can actually think about what is EOQ in this problem, and then what should be a safety stock level, and then we can check with these analytical solutions and see if the analytical solution actually performs the best. So continue with this exercise 10.24. If you calculate the economic order quantity, which is 27, now we need to actually calculate the average lead time, and then a weekly holding cost and a fixed ordering cost. So now we are actually talking about the weekly costs and the demand. And then we use a safety stock. So we calculate the reorder points. It's about 100 if you consider 30% or approximately 30% of safety factor. So excuse me. So this actually the new policy we worked out. So probably we can give it a try and see if this ordering policy will be better than others given in the exercise. So I actually implemented this experiment in the Excel, and then now you can see this analytical solution actually gives you the best, so actually significantly reduce the cost. So it also verifies analytical method actually also the reasonably good method, even if in the existed analytical method you did not actually consider the stochastic lead time. Okay, so far I have explained how to construct a inventory simulation model, but the conclusion actually told us the analytical solution may give you the best performance. So why should we actually consider simulation? The reason is actually the real world the real world inventory problem normally is much more complicated than the textbook exercise. So you often need to consider dependent demand, multiple items, dynamic decisions, and so on. So that's actually the reason why sometimes we need a simulation to evaluate the performance of your analytical solutions. So here we have this slides to talk about how to build a sophisticated inventory simulation model. So you can start with a standard deterministic model, identify the stochastic elements of the model, so for example cost, demand, and lead time, and then estimate probability distributions for the stochastic parameters. For example, normally the demand and the lead time can be stochastic, but actually sometimes costs can also be stochastic. For example, the raw material purchasing cost basically always fluctuating over time. And then replace the known quantities with the numbers generated from your distributions. And then basically we're talking about apply the stochastic distributions in the simulation model. And then run your simulation based on multiple replications. Actually, we should also add one bullet, so analyze the output. And then if you continue, you can see actually you need to recommend or make recommendations. So that's how you apply inventory simulation methods.